All right, so these could be your websites. And now it's my pleasure to welcome our esteemed panel to talk serverless applications. We have Rajoshi Ghosh, Guy Podjarny, and Mark Duiker. Welcome to Build.
Hi, hello.
Hi there.
Hi, how are you folks?
Good, good.
I'm pretty good, thanks. Yeah, very excited.
It is it is so great to see you all. I would love to hear from all of you who you are, where you're based, and kind of tell us what are some of the things that you are doing in your day to day.
Sounds good. I can get started. Hi, everybody. I'm Rajoshi. I'm one of the founders at Hasura. Hasura is an open source GraphQL as a service product. Basically, you point Hasura at your database or microservices and serverless functions, and Hasura generates a GraphQL API that you can consume directly from your front end applications. And at Hasura, my day to day is I work on all the growth aspects of Hasura, which basically means I spend a lot of time looking at what developers are excited about and patterns and trends and what they're doing. And so I'm really excited about like this panel because I get to share a lot of what I see with the GraphQL and serverless ecosystem, and looking forward to talk about that.
Cool.
Yeah, hi. My name is Mark Duiker. I'm an Azure FMP. I work for Expert in the Netherlands and doing consulting. Every couple of months, I work for a different client, and I advise them how they can best use Azure. And more specifically, I do a lot of serverless technologies within Azure and event-driven architectures, which I really like. Next to that, I'm also a co-organizer of Serverless Days Amsterdam, and we just had our virtual conference earlier this month, where Simona was actually giving a great keynote there. So thanks again, Simona.
Well, thank you so much both for joining me. And I wanted to kind of share that this is probably one of the panels that I'm most excited about as well, just because I've been an active member of the serverless community and I've been enjoying seeing serverless days grow so much in the past 2 or 3 years. For the past 2 years, I've actually co-organized Serverless Days London, and it's really great to be part of Serverless Days Amsterdam as well. And hey, Guy is here as well. Guy, do you want to maybe share a bit about yourself? What do you do in your day-to-day, and what links you to serverless as well?
Sure, and sorry about the sort of joyful technical glitches here. I am Guy Podjarny. or Gaipo. I am the president and co-founder of Sneak, where we deal with kind of helping you stay secure as you develop software, finding and fixing vulnerabilities in open source components and containers that you use. And I've been sort of on the serverless journey, for a good while now, talking about serverless security for the last bunch of years, and kind of a big fan of the motion here. So happy to discuss it further.
Thank you so much for sharing. And I'm assuming that a lot of the folks that have dialed in are actually already familiar with what serverless is, but there's always a different definition for serverless just because it's such a big misnomer. And I would love to hear from all of our guests today. What is their definition of serverless, and specifically through the lens of your experience with serverless. And Rajoshi, let's start with you. Can you tell us what serverless is and where would you use it?
Absolutely. So
sure.
To me, I think. Oh.
Go ahead.
So okay. Should I go first?
Yeah,
go ahead.
Go ahead.
Okay. Yeah. To me, serverless is actually about the way I see it. I look at it as about economics and accessibility. So I think we hear about the economics aspect of serverless fairly often, where you consume and pay for only what you use. But what I'm really excited about is the accessibility aspect of serverless. So you only write code, for what you need to do, and you can basically get productive and ship applications with lesser baggage and only focus on the code that you need to write. Say the business logic in your application, and not worry about how you have to manage and scale it. So yeah, that's serverless for me.
Cool.
Sorry, Guy.
What about you? What about you, Mark? Can you tell us, are there any servers in serverless?
Yeah, every time I hear that, I see the picture of Jeff Holland standing in like this data center with all kinds of empty racks. That's really still a funny image. But yeah, to me, service means that you don't have the responsibility of maintaining your own infrastructure and don't need to update your OS and those kind of things. So you don't have that burden. And like Joshi mentioned, it scales up and down automatically. You don't have to configure anything to get that in order. And indeed, the consumption model is essential, and you only pay for what you actually use.
Yeah. I guess if I chime in, I think both of those are really kind of great definitions. I think serverless has a little bit of an affiliation also with the function concept. So serverless as a whole is indeed about sort of, server management less. You don't need to manage those servers. You don't need to care about them. You don't need to care about capacity. But it also that's also true for serverless platforms like Fargate or some like Azure equivalent. It's just sort of systems that are that might spin up or down containers. I think serverless is oftentimes also affiliated with more of a programming model that is function oriented. That is almost like extreme microservices. Which is you really kind of modularize your code to small bits that are indeed, sort of a bit more, a bit different kind of architecture-wise, state, data, and the likes. And so I think when people say serverless, they mean both. Both are valuable, but they're not dependent. You can enjoy the lack of managing servers, patching them and managing their capacity while without shifting all of your application to this sort of function model.
Yeah, I love that, and I'm actually curious, Guy. I know you bring a wealth of experience in the security on the security side of things, and I'm curious what parts of serverless are interesting to you from a security perspective.
Yeah, I think serverless is fascinating security-wise. It's if I say sort of simply, it takes a lot of security responsibility off your hands, but it also allows you to really create a mess. If you think about different mistakes you could have. So I've actually kind of written a book about serverless with O'Reilly called Serverless Security, and we talk about a different shared security model there, in a model we call CLAD, which is the bits that you are still responsible for. Or maybe kind of going back a little bit, is when you talk about serverless and you talk about shifting more of that sort of server management responsibility to the platform, then the result of that is that a lot of problems, a lot of challenges, like simple one is patching those systems or denial of service. A lot of these things get offloaded to the platform, and that's awesome. You don't want to reinvent the wheel. But in the process, there's a whole bunch of the security concerns that still remain within your hand. And those really boil down to this CLAD kind of initial, which is code, libraries, access, and data. So you still have to think about vulnerabilities in your own code. And it's sort of no worse, no better than before, but you still need to worry about them. Libraries that you have, whether like you're not managing the OS, but you would still use npm packages, you would still use sort of Maven packages, and those might still get vulnerable over time. Access, that's maybe one of the biggest pitfalls, is like just configuration, permissions, who's allowed to do what, who's allowed to access a function, and then data. You have to secure that data. Nobody does it for you. And while those four they're not worse in serverless, but because a lot of the other things go away, right? Because the server patching and all these things move to the experts, then they do rise in prominence, right? Attackers seek the easiest way in. And so if you can't have an unpatched OS, you might have an unpatched function, right? That basically has like an outdated and equally vulnerable NPM library, right? Which is quite similar. So, on the whole, it's positive, but you have to kind of account for the areas that remain your concern.
Yeah, I guess I do love the idea of not only do I not have to care about servers, but now I care very deeply about security, but that's also being taken care of for me by some of this world-class security experts out there. So I love this perspective as well. And I think Rajoshi, I know that you at Hasura, you work a lot with GraphQL applications, and GraphQL has to do a lot with state. And we know that serverless is not necessarily great when it comes to state, or at least not in a way that we would expect it traditionally. And I'm curious, where do you see a good fit between GraphQL and serverless?
Absolutely. I think almost picking up from Guy, where, it's like, delegating to experts. So in this case, experts are delegating to services. So I think serverless works really well in scenarios where, everything that has to deal with state is sort of servicified. So you can consume or delegate this to a service, which is what I was talking about experts. So one of the ways in which GraphQL and serverless work really well together is when you can also access your data as a service, and you can use GraphQL APIs for this. So this is very good because your GraphQL API is basically an HTTP API that speaks JSON that can very easily be consumed by a serverless function. The other scenario where where GraphQL and serverless work well together is when you think about your business logic for the application that you're building is basically the serverless API, and the parts of your application that need to deal with state, and shared memory like query caching, these are delegated to a GraphQL layer that you then almost think of your GraphQL layer as GraphQL infrastructure that is dealing with these hard problems for you, and then the GraphQL service then triggers the serverless functions which run the business logic, which is separated from state. So these are two ways in which I think GraphQL and serverless work really well together.
I think that probably Mark now has a lot of things firing up there. I know that, Mark, you've worked a lot with stateful workflows and durable functions. And even though in a serverless environment, we don't necessarily have this traditional state where we maintain state between function runs, using stateful workflows, we can actually achieve some of that. Do you mind sharing a bit about what you've done with durable functions and what's your understanding of how they deal with state and some of the benefits?
Yeah, I really like the durable function extension for Azure Functions. So in this case, it's really specific. So the statefulness lies in the fact that the orchestrator is being persisted to storage. So if you have a workflow of several activities, then the state of that orchestration, so which activity has already been executed and which ones have not, that is then persisted. And that's really great for resilience, to increase the resilience of your architecture. And so if you're calling out to some kind of external API and that fails, the durable function framework can ensure that you can automatically retry that activity. And in case indeed, what is also nice that the persistence also makes sure that you don't pay for your function execution twice. So only the activity is running or the orchestration is running, but you're not being double billed for an orchestration, which is long running, and also your activities. So, and it's also a really nice programming model for developers because you just code your workflow. It's very easy to follow. You can also unit test it. Those are really very nice benefits, and I see a lot of companies taking use of it now.
Yeah. There's an interesting, sorry for jumping in, there's an interesting security implication to some of these because serverless functions, and sort of Azure functions and are so great at auto scaling and at sort of just paying for what you use that sometimes when you need to manage that state, like, you still need a state as sort of a part of your logic, and the result is you move that to some sort of backend services. So if you use one of the sort of the Azure services or such that also scale really nicely, that's not a problem. But once you reach out to maybe some third-party service, some sort of APIs, you're sending some text messages through some sort of third-party entity, and they don't scale. There's actually an interesting sequence of examples of denial of service attacks that get past the sort of the service layer, which is too good, too scalable, too fast. And you just kind of moved over the bottleneck. So I guess the only word of caution from a scale and security perspective is to just be mindful of just how scalable is the system behind you. You're only as strong as your weakest link.
Yeah, definitely. That is also the whole idea about the so-called back pressure, which is a term borrowed from fluid dynamics. So indeed, you can have a bottleneck like an external HTTP API or indeed your storage, which just cannot handle your production load. So that's still quite a common thing that I usually help teams with. I can remember an example where they had a service bus and it was trying to pump data to a SQL instance, but the SQL instance couldn't handle it. It couldn't scale as quickly as your functions could scale. So you need to be really mindful of your dependencies, check the rate limits of your APIs, because you can easily need to do a denial of service, or you encounter throttling. So it's definitely worthwhile to indeed do some good research of all of your dependencies, and indeed if you are limited by them, make sure you indeed use an existing APIs, like for instance Drupal functions, so you can do retries, or use something library like Poly, for instance, so you can do circuit breaker patterns. There's a lot of things out there which really can help you a lot, so you don't have to reinvent the wheel. So that's really nice.
And we do have a live Q&A, and I wanna address one of the questions here. I think all of you at a given point in time you've mentioned serverless APIs, and one of the questions here is, I do have a normal API and I can build a serverless API. Why would you recommend building a serverless API versus a normally hosted one?
A lot of things can come to mind. It depends. It's used a lot, because if it's only used very infrequently, the load is different over time. Then a consumption model like Azure Functions, and also then behind an API management, which is also consumption based, can be really worthwhile, because you only pay for what you use then. So if it's like a small environment, not under a high consistent load, then it could be very well worthwhile.
Yeah, I think thinking about those, like for your specific use case, whether the API is better off as a serverless API, depending on what the use case is. And like Mark mentioned, if there's bursty traffic that you expect that's not consistent, where you don't need to bear the cost of having a server running the entire time, that's kind of when you think about what you want to run in as a serverless API, and one as a hosted API.
Yeah, and I'd say that I think in most cases it's not that you literally migrate the API as is, from running on a server, unless indeed that sort of API layer itself is costly to operate, but rather that you build a new API. And so in that sense, I think what serverless gives you is agility. It's very independent. It can act as a sort of middleware that sort of sits there and is edited without disrupting the system, so you can evolve it and kind of build it and maybe cover up for gaps that the backend API doesn't have it. Like for instance, indeed, if you're sort of adding a GraphQL, or if you're adding something a little bit less elaborate, or you're just sort of changing your data model, you can compensate for it in a service layer very elegantly, very confined, very kind of contained within that layer. As you over time evolve, both of these are now internal, right? Like the client and the new API layer, and so you can evolve your sort of backend API. So I think like in most cases that I've seen, it's not that people take an API as is and they migrate it to serverless, but rather that they build a new API layer to support maybe like a more sort of single page app or sort of mobile app that they're building, or a different type of integration, and they use that sort of API layer as some modernization, some improvement over the previous API they've had.
I like that thing where we add the API layer, and I think I've used GraphQL and serverless a lot like that as well, where almost like GraphQL is my thin layer on top of my existing services. And the thing that I like the most about that approach is that it allows me to have a unified view of where my API endpoints are, bring in that documentation for my endpoints, and also have a single entry point that auto scales magically. I wonder, Rajoshi, are you seeing other use cases with GraphQL and serverless?
Yeah, I think I'd love to sort of spend a couple of minutes talking about how GraphQL subscriptions work with serverless. And so GraphQL subscriptions are basically incredible to work to build, real-time systems. And so we spent a lot of time thinking about, how to scale GraphQL subscriptions, and also how, what are the new architecture patterns that for building applications with GraphQL subscriptions and serverless. And so we put together something called the three-factor app architecture. And so let's talk about a scenario of, say, a food delivery application that you have to build. So you place an order to a restaurant, and that's essentially a GraphQL mutation. And in order for your order to be fulfilled, there's lots of business logic that has to happen in your backend. So for instance, let's say you need to assign a delivery partner, and you need to make a payment, and the payment is probably calling out to a third-party service like Stripe. So both of these business logic both of these features can basically be serverless functions and can just be pure business logic. And then what happens is once this business logic is executed, you can publish the result to a data store or an event queue that the GraphQL service is connected to. So the serverless function executes. Publishes the result, and then the GraphQL service picks it up from this data store and then delivers it directly to your front-end application via GraphQL subscriptions. And so we actually have a whole example, like sample code, some videos about how this scales and how this works when there are failures in the middle on the three-factor.app page. So anyone who's interested in reading more about this, I would definitely encourage you to go check it out. We've also been, even while we were putting this together, we organically have been seeing people in our community use these patterns to sort of get GraphQL and serverless to work together. And so that's been very exciting.
Guy, you mentioned there a lot auto scaling and function endpoints and function as a service. And I know that from a security perspective, that might be very interesting in terms of you are now in a situation where there's a lot more functions. Maybe function proliferation is something that we can refer to. What kind of challenges does that implicate for security?
Yeah, I mean, I think that's really kind of hitting the nail on the head in terms of the biggest security risk I see with serverless. I mean, I think when you think about serverless, again, you can think of it as extreme microservices, which implies you can scale up and scale down. So every function can be more resilient. So it can be, it can scale up and down, more specific to it. It can have minimal permissions, so only, two of the functions actually can access the data, right? Versus kind of the full monolith application, because that was your granularity of permissions. You can do things in a much more refined fashion, and you can sanitize inputs, or secure the surrounding, the perimeter of every function. Every function becomes a perimeter. And that's awesome, but that's kind of the idyllic reality. And in practice, we're all lazy. So we are trying to do something that is right. And the challenge is that that we don't apply those sort of core hygiene practices to every function. And at the end of that, we remain with a mess. So, if you thought that it was hard to wrangle, 1,000 servers and keep them patching, patching a server is easy. Patching 1,000 servers, 10,000 servers on a recurring basis, that's hard. So same goes for a function, right? Like maintaining a function, maintaining it secure, that's easy. But, when you get to the point where you have thousands of functions and they change constantly, keeping the hygiene on it, it's nothing fancy. It's not some advanced persistent threat. It's not some sort of, country that's after you. It's really about the basics of ensuring that the libraries that you have in there are patched, is ensuring that the permissions are not explosive. Like permissions have this tendency to sort of, expand until somebody adds an asterisk, and then they're just, it's all permissive, but there's never like a motivation to decrease them. That kind of never happens. And so So that to me is the problem. Like that's the risk, right? Is that we wake up tomorrow with this norm in the industry of having, this huge amount of functions, because it's so easy to deploy a function, right? Like it really comes down to like, why wouldn't you deploy a function? It's easy to write, it's easy to deploy, it doesn't cost you anything until it's used. Like why not? And the only reason not to is really that sort of looming security risk of you can do it once, but if you did it again and again and again, you're going to be in trouble. And so my kind of guidance, my primary guidance is just like when you walk into serverless, when you're going past the sort of I'm playing with functions, I ran a couple of cool things. Think about the practices, think about your methodologies, put some basic kind of monitoring in place, connect them, monitor those functions for vulnerable libraries, monitor them, monitor the permissions of them to see that they haven't exceeded, maybe do some cleanup, on a recurring basis. And if you do that, you'll be better off, than you were pre-serverless. But if you don't do it, it's going to be really hard to kind of unwind that wheel, because you'll have these functions that nobody knows why they're there and why did they have that permission, and can you touch them? And everybody is going to be too afraid to touch, right? And then they just become there and they remain risky.
Yeah, and in addition to that, I would, especially for migration scenarios, I would always say, you'll also mention it, Guy, from really look into the code, because it's very unlikely that you want to migrate your non-serverless code to serverless situation, because you're also dealing with maximum execution time and things like that. So usually you have to break your code into smaller pieces. But then, of course, you have the function app container in Azure, and that contains multiple functions. But I also see a lot of teams actually putting, let's say, dozens and dozens of functions in this function app. Sometimes that might be useful and desirable, but oftentimes it's also not, because you might have different scaling requirements for all those functions. So yeah, specifically for those migration scenarios, be very careful of how you actually split up your code between functions, but also split up your code between different function apps, to also be very granular on indeed the security rights you assign them, and also how they actually scale and perform. And always make sure you start with the CI/CD pipeline from the start, indeed, to make sure you have a robust deployment going on.
Yeah, absolutely. And I think you can remember that the people basically revert to the easiest thing. So like when Serverless Framework came out, it made deploying functions very easy, which is great. But their default is that you set up permissions for one manifest file, and basically those permissions are inherited by everybody and all the functions in that file. So the easiest, you could technically create a manifest file for every function, and you could specify permissions for every function, but it's harder. So people don't do it. It's developers. Developers have a lot on their plate, and so again, it's just about investing and making it easy to do all these things, right? Or making it hard to do the wrong thing, as Mark suggested.
You almost talked there a bit about tooling, and I think that with serverless, because it is so easy to deploy things, it's also cheap. Like I'm guilty of having deployed like hundreds of functions and not using them anymore, but because it doesn't cost me anything to have them sitting out there in the cloud, that also means that I will not go back and undeploy them or delete them and maintain my code, which probably doesn't make me a great developer from that perspective. But I think that it's worth calling out and talking a bit about some of the best practices that all of you recommend in this case. So I heard that we should make sure that our function only does one thing, and we should make sure to manage those functions in a way that we have granular access defined for them. And then state management is important. What would be your recommendations in terms of best practices? And then are there any tools that actually help you maintain those best practices and describe them in a way that they're easy to incorporate?
Something very specific to durable functions, which I often encounter, is of course because it is stateful, because the state is, storage is used, table storage is used. And I think it's important also to clean up the history of those orchestrations. And so by default, all the history is kept of the orchestrations, so which might be good for auditing purposes. But if there's no need for using that historical information, then you should add a timer trigger to your function to make sure you clean it up on a daily basis, for instance. So that's a very small effort which you need to do as a developer. But maybe someday, it can be built into the framework to clean up your historical data regarding function orchestrations.
I think first of all, I would say that that's probably the biggest shortcoming at the moment. Like serverless is super promising, but it is still fairly immature. And I think there are some core concepts that are still logically not fully resolved in the industry, like what's the whole? You have all these different functions. What's the completeness? I would say serverless is almost like the old school kind of enterprise Java beans and all that. Like they really are about sort of small units of code. And I'm thinking functions here, right? Just to kind of clarify from the beginning, not just serverless as a system. And so a lot of the tooling really boils down to be in the pipeline, is basically to sort of, be monitoring what you're deploying. And so all sorts of quality and test tools, that, or per your language would apply there, just look to do them. And then the second is almost an asset management element. Like I'd be remiss if I didn't say Sneak, should be one of those, we'll connect and we'll kind of tell you if one of these, if you're using kind of vulnerable libraries in any of them. But also I think most of the APM vendors now have the ability to run it. And that helps you like to monitor functions. It's a little bit hard because functions have very low tolerance because they get booted up and down and they run around. They have very low tolerance to kind of latency delays. But still, most APM vendors have some form of, like New Relic and the others, have some form of serverless support, which I think is useful even just to sort of get into the muscle of asking questions about how well they are performing and finding out those functions that never get invoked. And as we talked before, get them off the list, delete them, remove them, put them in some sort of playground, unpermissive sandbox account.
I think I'd just like to add one sort of small thing to here, which is almost like, like adopting serverless almost puts sort of the pressure on, ecosystem vendors to also sort of the managed services. Basically, adoption of serverless is almost like directly proportional to like servicification of everything else around it, and sort of putting the pressure on the ecosystem to also sort of mature along with like tooling around serverless. So I think that's something that we're going to see a lot of, like similar to some of the things that Guy just mentioned.
And we have another question coming up from the live stream. There's someone that has asked whether you've seen integration between on-prem or legacy systems and serverless applications. Have any of you worked with these kind of scenarios as well? And maybe you care to share what's worked and what not.
Not with functions directly, not with Azure Functions, but with logic apps. So that is one which of the few offers a connector that you can actually connect to on-premise networks with. But to be honest, I haven't done much myself with that.
Yeah, and I think what I'd like to add here is that actually when it comes to Azure Functions, the runtime is open source. So if you're in a place where you're still running on-prem or you're still running in your legacy systems and you want to kind of start adopting this serverless programming model and get ready for a migration, you can still get the serverless runtime and the Azure Functions runtime and deploy it in your own servers, or you could also be using things like Keta, which is our serverless Kubernetes option for serverless functions and serverless platforms. Now, I know we're almost coming at time, and I'm curious if you can maybe share one thing amongst each other that you are excited to see coming to serverless, or maybe an emerging thing that you're curious about.
I have something here, which is definitely a biased answer, but we have you asked Simona. We have a feature actually coming out as part of our next release, which is due in a few weeks, which is called Schedule Triggers. That is particularly exciting, again, with the sort of intersection of for using serverless. So couple of scenarios in which you can use it. One is like, say, you have to send an email at 5 p.m. every day. So you kind of have a scheduled trigger for this that triggers the serverless function at 5 p.m. to kind of actually run the business logic to go send the email. And the other sort of aspect to this is when a scheduled event, when say, you want to send an email 7 days after a user is registered as part of, say, a drip campaign or something. And so you can also set those kinds of things up, and trigger serverless functions at a particular time time in the future to run a particular function. So this is something exciting that that we have coming up, that which is which is very relevant to the serverless ecosystem, that we're excited about.
Cool. I'm excited about that as well, or Joshi. Anything from you, Guy and Mark, even if it's not serverless related, if there's one pick that you want to share with everyone, and conscious that we're running against time. So
I just want to share that whatever you're building, make sure to look around what's already available in Azure or on GitHub in open source libraries, because there is so much already out there. So please try to reuse as much as possible, and do not need to reinvent the wheel.
Oh, Guy, I think you're muted.
Sorry about that. I'm full of technical problems today. So two quick ones that I like in the ecosystem are, one is the Kubernetes working groups around application definition, which are important, which I think you should keep track on them. And second is solo.io has some pretty cool functionality that actually helps, related to that previous question, connect different types, because serverless oftentimes, might be right for some of your system and not all of it.
Your daughter is so awesome. Sorry, I couldn't. All I heard and all I saw was your daughter. Hi. Amazing. Thank you so much all for joining us, and thank you for the really awesome discussion and for pushing the boundaries of what serverless can achieve. If you want to hear more and learn more about serverless, check out our courses at Microsoft Learn, aka .ms/LearnTV.